Hello, everyone. Welcome to the Math Magician's Den. This is the Herm Dog. We're going to talk about implicit differentiation again, and we're going to do a problem here. And this is the graph I'm giving you. X squared times y squared minus 9x squared minus 4y squared equals 0. This is how that graph looks. This is obviously not a function. And there is a coordinate on this graph right there at -4, comma 2 radical 3. And what we're going to do is we're going to find the slope of the tangent line at that point. And we're going to write the equation of the tangent line at that point. And we're also going to talk about what the normal to the curve would be. So first of all, I've got to find the derivative here. The derivative is going to involve implicit differentiation, and it's also going to involve basically a product rule. And product rules, I worry about product rules all the time because product rules, I have my students get that wrong all the time. This is x squared times y squared. What's the derivative of x squared? Well, it's 2x. And I multiply that by the second part, which is y squared. Then I add x squared. And what's the derivative of y squared? Well, it's 2y. And using implicit differentiation, I've got to put y prime there. What is the derivative of negative 9x squared? Well, that's 18x. The derivative of negative 4y squared is 8y. But wait a minute, what's the derivative of y? Y prime. And then this is all going to equal 0. Now, very quickly here, we can solve for y prime rather easily. So here's how I do that. This term and this term are going to get moved to the other side. So I'm going to add the 18x. I'm going to subtract the 2x, y squared. Now, anything that's left over here and here that's multiplied by y prime, I have to divide by that. So I'd have to divide by the 2x squared y in front of the first term minus the 8y in front of the second term. And if I reduce this, my y prime is going to be equal to, first of all, they're all divisible by 2. They don't all have an x. They don't all have a y. But if I divide everything by 2, I get 9x minus xy squared all over x squared y minus 4y. There is my derivative. Now, how am I going to find the slope of the tangent line so that I can write the equation of this line? Well, the slope is simply use the derivative and plug in these numbers. So I'm going to take 9 times -4 minus -4 times 2 radical 3 squared all over. X squared would be -4 squared times 2 radical 3 minus 4 times 2 radical 3. So on the top, I'm going to get -36. These two negatives cancel, gives me a plus. 2 radical 3 squared is going to be 12. 12 times 4 is 48. It looks to me like the top of this fraction is 12. On the bottom, I get 16 times 2. That's 32 radical 3 minus 8 radical 3. That comes out to be 24 radical 3. And if I do some reducing, I get 1 over 2 radical 3. You can't have a radical on the bottom, so if I multiply by radical 3 over radical 3, I get radical 3 over 6. That is the slope of my tangent line. Now, wait a minute. How do I write the equation of my tangent line? If you've watched some of my previous videos, I always use point slope. And here's the reason I use point slope, because I really have a point and I have a slope. So let's use point slope. It would be y minus 2 radical 3 equals my slope, which is radical 3 over 6 times x minus -4. So this would be the equation of my tangent line at that point. Now, what's great about Desmos, not only can I draw a problem that's not a function, draw a graph that's not a function, I can plot the point and I can plug in this y minus 2 radical 3. And this is going to be equal to, my slope was radical 3 divided by 6. And this is going to be multiplied by x plus 4. And if you look at that, that is definitely the equation of the tangent line at that point. Tangent lines touch the curve at that spot at one point. Now, what is a normal to the curve? Normal, Normal. The normal to the curve is just perpendicular to the tangent line. How do you write an equation that's perpendicular to the tangent line? Well, the slope would be the opposite reciprocal. So I would take the opposite reciprocal. Obviously, this is not simplified, but you can tell the normal to the curve is perpendicular to the tangent line. It's going through the same point, so I'm still going to have 2 radical 3 and the negative 4 is my coordinate. But I just flip and change the sign on the fraction for the slope. Now, obviously, I can simplify this. I can cancel a radical 3. This would come out to be 2 radical 3 would be my slope. You'll see this in just a second if it's simplified. Boom. That is how you find the equation of a normal line to the curve. I hope this helps. This is one of the applications we can use with implicit differentiation. If you like this video, please hit the like button, and I'd appreciate it if you subscribe to my channel. I'll be posting more videos as time goes by.